Hello, welcome. Today we'll be discussing about the question called given a linked list, print middle element of the linked list. So they'll be giving us a linked list. We need to print middle element, basically middle element of the given linked list. So let's take this example 10, 20, 30, 40, 50. How many elements? We have five elements. So we need to print the middle one. Obviously, this is our middle element. This is our middle element. But how we can know? We don't have indexes or anything for this linked list, right? Like this is not array. This is to contain 0, 1, 2 and all. But how we can know this is our middle element? This is our middle element. How we can say that? So basically there are two ways. First way is to count total number of nodes, count total number of nodes and divided by 2. Count the total number of nodes and divide by 2. As you know how to count number of nodes, you count them and divide by 2, which will give you half. Okay. And second thing is tortoise and okay, tortoise and hare method. Tortoise and hare method, which is also called as two pointers technique. Two pointers technique, where those two pointers are named as slow, slow, and also slow and also fast. Slow and also fast. As you know, right? Tortoise, hare, how they go and all. So that is what it is. Slow and fast pointers. So these are the two ways where we can, the simplest way is to count total number of nodes and divide it by 2. And second one is tortoise and hare method. We will see how exactly the slow pointer, fast pointer, or these two pointers have been used and all. We'll see one by one. So first thing first, we'll be seeing about counting total number of nodes. Counting total number of nodes and dividing by 2. So let's take an example. Let's see how well this first approach works. So first approach, let me write down that. So let me take down the example. Let me take down the example 10, 20, 30, 40, 50, null. How many nodes I have total? Let's take that. This is the one of the example. And let's take one more example also. 10, 20, 30, 40, 50, 60 and null. 60 and null. So I have taken two examples. I have taken two examples. So let's see how these two examples will help us to understand this two both approaches basically. So let me just keep this out. Yes. Okay. Let's do with the first approach. What is our first approach, guys? First approach is count and divide by 2. Count and divide by 2. This is a simple one, right? Now let's start counting the number of nodes. So how? So this is the head pointer. This is the head pointer given to us. And from this linked list, this is the head pointer. So let's take this one. Let's see. So let's go with the first example. Let's go with this one. So this is first node. So count is 1. Second node, count 2. Third node, count 3. This is the fourth node, count is also 4. Fifth node, count 5. After that, I got null. So count in this particular example is, count of this example is, count as 5. Count as 5. Count as 5. What is 5 by 2? What is 5 by 2? 5 by 2 is 5 by 2 is 2.5. 2.5. 2.5, which means count is 2.5. Now, if we can't take 2.5 as the value, so we have to take its round value, which means we should take count as 3. Count as 3. So if you store this 2.5 into integer, this will become 2 plus 1. You need to add plus 1 to make this 3. Count plus 1. Okay, count plus 1. We need to do mid count by 2 plus 1 because of this round 0.5 value that we are getting. So now we need to, third node is our middle node. Third node is our middle node. Okay, guys, I hope this is clear. So this is your first node, this is your second node, and this is your third node, which is the middle node, Okay. Now going to the next example. Here count is how much? Here count is how much? Count is 6. Count is 6. Obviously 1, 2, 3, 4, 5, 6. So count is 6. So 6 by 2 how much? 6 by 2. We don't have any point values. We'll get directly 3. 3. We'll get directly 3. If you take 3 plus 1. Okay, if you take 3 plus 1 according to the above one, you will get 4. So which means this is your middle node. This is your middle node. But if you observe in this linked list, okay, in this particular linked list, what we have, okay, we have 6 number of nodes, which is even. So it will not have any middle point. These two can be considered as middle nodes. These two nodes can be considered as middle nodes. 30 can also be a middle node. 40 can also be a middle node because we don't have any equal thing, right? We don't have a proper thing to divide it into two halves. So these two can be considered as a middle nodes. So according to the process that we did here on the right side, okay, our middle node is 40. Our middle node is 40. So this is given in the question, guys. Don't need to worry. So we can print in this example, in this question, we can print any one, 30 or 40, both are fine. But most of the questions, they'll clearly mention which node you should consider as a middle node. So no need to worry on that one. So yeah, so now 40 is your middle node. So this is what we need to do, guys. This is what we will do when you are using count value. Count value. So let me write the code for this one. Let me write the code for this one. So first thing we need to count. We need to count. So let's take temp equal to head, count equal to 0. Count equal to 0. Now while temp is not equal to null, okay, temp is not equal to null, I am counting. So count will be obviously plus plus and temp equal to temp dot next, temp dot next. So this is how we will do a count. This is how we will do a count. Okay. After counting, what I need to do? After counting, what I need to do? I need to find out a mid. So m equal to c by 2 plus 1. C by 2 plus 1. Why we are adding plus 1? Because we are getting, if it is an odd value, we are getting point values, like the decimal value. That's why we are doing plus 1. So now m equal to c by 2 plus 1. After that, this value, what will be the value of m? What will be the value of m here, guys? What will be the value of m? If you take the value of m, value of m will be equal to 4, equal to 4, which means I need to print the fourth node. I need to print the fourth node. But do I have address of fourth node? Do I have address of fourth node? Obviously no, because I need to start from here again. This doesn't have index 0, 1, 2, 3. This doesn't have indexes, right? We need to go to the fourth node, which is our 40, which means I need to start iterating from the first node again. I need to start iterating from the first node again. This should be my first node. I'll see this is my second node, this is my third node, and this is my fourth node, which I'm searching for, and I will print this fourth node. Okay, so this will just give us an assumption what will be the node count, nodes position. Okay, that is what it is. So now let's jump into that one. Let's see how to print that node, how to go to that fourth position. Okay, how we'll go. So let's take c equal to 1 or else position equal to 1. Why I am taking position equal to 1? Because my temporary node is positioned at head. Temporary node is positioned at head, which means I am already pointing to this node. I am already pointing to node 10, which is first node, which is my first node. That's why position is 1 and I'm pointing to this node. What I will do, I'll simply go to next node and I'll see for the position. What is the position of this one? Again, I'll go to next node. I'll see the position. Again, I'll go to next node. I'll see the position. In that way, we will be moving. So how many times? How many times we need to move? Let's see that. While while position is less than position is less than mid value, position is less than m value, then move your temp equal to temp dot next. Okay, this particular loop will move your position to next value. Now let's see that one. Let's see that one. Let's say initially I'm starting at this place. Initially I'm starting at head. What is my position value? 1. Now I go to the, so 1 less than, what is my M? 4. 1 less than 4. Is that true? Obviously this is true. I'll move my pointer to the next value. I'll move my pointer to the next value. Again I'll see this value is increased. This value should be increased. So I need to increase the position. So I guess we are missing that one. So after doing position plus plus. Why I need to increase position? Because as I'm moving to the next step, next node value will be, next node position is obviously changed. That will be the next node, second node. That's why we are doing position plus plus. So whenever position is less than m, we'll simply move to next node, we will increase the position. And at the end, we will simply do sys dot out dot print line temp dot value, temp dot value. So let me show you the example also, guys. Let me go through. This is your first node. Position is 1. Now 1 1 less than 4. 1 less than 4. Is that true? Obviously, this is true. What is the first thing I will do? I will move to the next pointer. Move to the next node. Move to the next node. Okay, I move to the next node. Next count will be updated to, position will be updated to 2. Position will be updated to 2. Again, 2 less than 4. 2 less than 4. Is this true? Obviously, this is true. So what I will do? I will move to 30. I'll move to 30. Now I'll increase this position to 3, third node. Now again I'll move, I'll see condition 3 less than 4. Is that true? Yes, this condition is true. Again I'll move to 40. I'll move to 40. Now 4 less than 4. Is that true? Is this condition true, guys? Is this 4 less than 4 true? Obviously, this is not true. Now, my temporary is pointing to 40. Temporary is pointing to 40. So, I will simply print that value. I will simply print that value. So, in this way, we can do with the count. We can do with the count. So, time complexity will be n plus n. N plus n, where n is nothing but, where n is number of nodes. N is number of nodes. If you take in totality, it will be simple thing. Big of only n. Big of only n. So in this way, we can use count by 2 method. Count by 2 method. Now let's see another approach. As I said, let's go to the another approach, which is tortoise and hare approach. Tortoise and hare approach. So another approach is, guys, tortoise and hare method. Tortoise and hare method. This is one of the famous method, guys, which is also called as two pointers technique, where those 2 pointers are named as slow and fast. Slow and fast. So let me give you a brief on this one. 2 pointers approach. So tortoise and hare method, 2 pointer approach, or whatever it is, guys. So this is called as tortoise and hare. Now let me give you a brief on this. Let me give you a brief on this one. So how this works? How this works? As you know that, as there are the names of the pointers indicates as slow and fast. Okay, there are 2 pointers. There are 2 pointers, slow and fast, where slow will go one step, slow will go one step, and fast will go 2 steps. 2 steps, which means if you observe the ratio between these two, if you observe the ratio between slow and fast pointers, whenever fast reaches the end, whenever fast reaches the end, okay, slow will be exactly in the middle. Slow will be exactly in the middle. How we can say that? How we can say that? As you know, it is going 2 steps, it is going only 1 step, which means 2's half. Let's say if slow is going second step, fast will move to fourth step. If slow is going to third step, this will go to 6 steps, which means exactly half. If fast reaches the end, slow is in the middle. Slow is in the middle. Okay. I hope this is clear, guys. This is how the slow and fast pointers work. This method is called as tortoise and hare method, where tortoise is slow, hare is fast. This is what, guys. So let's see how we can actually implement this one. So let's take this example. As I said, this is your slow, this is your fast, this is your slow, this is your slow. Now let's move. As we already know, that slow will go to which pointer next, only one step. Slow will moving to only one step. Now slow reached here, now fast will go to step 1, step 2. So it will go step 1 and step 2, so it goes 2 steps. Now fast is at 30, 30. Again slow will move to next step, slow will move to next step, only one step. Now fast will go 2 steps again, fast will go 2 steps again. Now if you observe, my slow reached the middle, and my fast also reached the end of the list, end of the linked list, which means fast of next is null, this is your first condition, here in this example, fast of next is null. Okay, slow every time it jumped one pointer, one step ahead. Fast jumped 2 steps, so whenever fast reached the end, slow is exactly at half, the half. So now let's go to one more example. Let's see what exactly this will do. So let me move this example little down. Now, as we know, this is our slow and this is our fast. Okay. Now, as we know, slow will go to one step ahead. Now this is our slow, and fast will go to two steps. So this is your fast. Did we reach at the end? Do I have anything null next of fast? Do we have anything null of next of fast? No, I don't have. So I will move my slow pointer one step ahead. This is my slow, and fast is moved 2 steps. This is my fast. Now again, I'll move my slow. I'll move my fast to null. Okay, 2 steps. 60 is first step, null is second step. So if my fast reaches null, okay, my slow will be in the middle, which is 40, Okay, guys, I hope this is clear. So if the number of elements in the list are even, my fast reaches null. My fast pointer reaches null. If number of elements in the list are odd, my fast reaches last element. So in this way, we need to write our condition. So let's take 2 pointers. As we know, slow is pointing to head. Fast is also pointing to head. Okay. Now what we need to do? As a first step, okay, I need to move how many steps slow? Slow equal to simply slow dot next. Slow will move 1 step. What about fast? Fast will move 2 steps. Fast dot next. Fast will move 2 steps. Fast dot next. How many times I need to move? I need to move till fast is not equal to null. Fast should not be equal to null, and fast dot next also should not be equal to null. These are the two conditions. This is for odd, this is for even. Okay, and at the end where I will have my answer. So system.out.println slow dot value. So in this way we will use 2 pointer technique. So here time complexity is, what is the time complexity here, guys? Only big of n, not even n, it will be n by 2, because we are going to only half of the list, only half elements have been reached. Okay, so in this way time complexity is reduced using the slow and fast, slow and fast pointers, or whatever, tortoise and hare method. So this is what the code for the particular example. This is what the code for the particular question, guys. I hope this is clear. So this is the time complexity and this is the approaches that we have seen. I hope the question is clear to everyone. So thank you, guys.